Hi, and welcome to episode 3 of Build Your Own Video On Demand Platform. I'm Sean Ray from Amazon Web Services, and with me today...
I'm Rob Carr. I'm also from Amazon Web Services, and I'm one of the media and entertainment specialists.
And today in episode 3, we're going to discuss playback and how the content gets from your provider and onto your playback device. Rob is a specialist in this area, and he's going to talk us through the architecture he has on the board.
Sure. So the architecture that we see on the board really is dedicated to providing a world-class user experience and allowing the user to discover the content, to search for content, to see metadata about the content. So that's, things like the actors that are within the films or the series that we're going to be showing. It's allowing them to have recommendations provided to them. So what do we think this user might want to see? And it's about delivering that experience in a way that's really, really fast and really resilient, and robust to failure. Because we know that as soon as users start to receive a slow experience or they start to see things like images not loading, that really, stops users from using the service and getting out their credit card.
Okay, and I notice in your architecture up here you have AWS WAF as one of the services. That's not really a service, a security service that I expect to see in this architecture. Can you talk me through that?
Sure. So content security is really, really important. We have rights holders that have provided the content to us that we are then providing to users, and making sure that remains secure is really, really important. And so the security throughout this entire chain that you see on the board, it has to be as secure as we can make it, and WAF really is the front door to that piece. So this is where we can stop things like the OWASP top 10 list of vulnerabilities. It's where we can do things like blocking specific IPs or specific IP ranges, and we can respond to threats that we see lower down in the tiers automatically or manually.
Okay. And I noticed, past CloudFront and WAF, where you're doing the CDN, you're actually getting into API Gateway. What are we actually hosting in this area down here?
So if you think about the user with their devices at the top, so that might be companion devices like their phones, it might be connected televisions, it might be native websites on laptops or on desktop computers. This is the architecture which is dedicated to providing that user experience. So if you think about any of the common video on demand services that you would have used, you'll be pretty used to seeing bars or ribbons which have different pieces of content within them that you can scroll across, usually in different categories, usually based on recommendations that are made to you. And so if you think about when the user is browsing on their device here, if they're using a mobile application, it's going to be talking to APIs that we host. And that really is where API Gateway and Lambda come into providing the data back to those devices.
Okay.
So.
I guess one of the things that our users really want to see, we're into episode 3 now, and the idea is that we can, show, I guess, the user journey through. So could you draw out, I guess, the user journey through this particular playback architecture?
Yeah, absolutely. So the first touch point, as we've already discussed, is WAF, and that goes hand in hand with CloudFront. These two are linked together. So the device is actually going to be connecting to a CloudFront edge location. And this is where content can be cached. So if you think about providing that first-class user experience that I mentioned earlier, if we're loading images, we want them to load really, really fast. We want that to be really snappy. We can cache that content in CloudFront near to the user to deliver that first-class experience. And we can also block, spurious actors or malicious actors, using WAF at that point. It also allows us to drop, 99% of other attacks that we might see out there. Things like UDP reflection can all be blocked here before it gets into the lower tiers.
And you talked about content being served out close to your users. How do we do something like, one of the things that we see in content providers, I guess, is GeoIP restriction and making sure that content is only available in your country. How is that, achieved at this tier, or is it further down in your architecture?
Yeah, absolutely. So there's a number of options there, and content providers, as you mentioned there, will mandate or provide in the rights agreement where you're allowed to show that content. Now, we might not want to block it at CloudFront. We actually could do that using Lambda at the edge, but that isn't typically the way that we would approach this. Typically, we want to apply some business logic to that user's location. So CloudFront can tell us which country it believes that user is located within, and we can pick up that information further down the chain within our business logic in Lambda to make sense of that.
Okay, so we talked through geolocation in CloudFront. Caching is very important to media streaming. Can you talk through the other functionality that CloudFront's providing?
So CloudFront has the capability to split inbound requests based on path to different origins, and that's really important for the architecture that we're showing here. A simple example of that would be that if we have image requests, we don't want to dedicate compute time to serving those images back to the user. We want them to be served directly from S3. So they will have pre-processed when we ingested that content, and we can just serve them straight out of the S3 bucket here. And obviously we want to cache them in CloudFront, which means CloudFront sat in front of that S3 bucket. So what happens is when a request comes in for /images, CloudFront uses rules which direct that request down to S3. And the first time that image is retrieved, it comes back up into CloudFront and it can be cached there, so that any subsequent requests from other users will be served, much quicker, because it doesn't have to come all the way back to the origin.
Okay.
The other half of that is that requests from users' devices, so their mobile phones, when they need to make calls to log in or to search content or to browse the catalogue, will need to be directed to an interactive, a dynamic origin, and that's API Gateway. So those requests will come down here. And that's really kind of the crux of what we use in CloudFront for in this architecture, is caching and making that decisioning between the two different origins.
Okay, and then I noticed underneath API Gateway, you've actually got these Lambda functions and step functions in the middle as well. Can you talk through this business logic layer?
Sure, so we're actually representing a number of different functions here in Lambda. A really simple example would be something like login and profile creation. So when the user first comes to the service, they're obviously going to need to create a profile. We've gone with a microservices style approach here, where the logic to create the profile will be contained within a single Lambda function. And API Gateway can route that request to create the profile to the relevant Lambda function that's going to achieve that outcome with that business logic inside it, and then respond appropriately to the user. Inside of here, you're going to have all your business logic. So determining, is the user in a location where we allow them to sign up? We might process their credit card details or store them, because you can build fully PCI compliant architectures with API Gateway and Lambda. And we're obviously going to need to store some information about the user. Now, to do that, we've chosen DynamoDB, and that's a really fast NoSQL store, which is going to allow us to store information about users. It's going to also allow us to store all the other types of information that we need to hold in order to create the whole service. So information about our content, about our assets, about the rights that we have for those assets. But let's continue with the user profile creation. So what's going to happen is the request comes in through CloudFront, through API Gateway to the business logic. The profile is created, assuming that all of the tests within the business logic pass. It's created within the user profile table here within DynamoDB. And then the response comes back from Lambda through API Gateway to CloudFront to that end user. And obviously that type of request we're not going to cache in CloudFront, but we still do benefit from having CloudFront in front of our API for dynamic requests. It will still speed up that user experience, which, as we've talked about, is very, very important.
Yeah, latency is definitely important in those types of interactions. And I noticed that you have step functions in the middle, which is really an orchestration service. What are you using to orchestrate in this flow, and why is it important?
So the example that we just talked about was a synchronous interaction. The user hits the button to create the profile on their device. It flows through the business logic, the information is stored, and then the response is routed directly to the user. But let's say that we were creating a subscription VOD service or a transactional VOD service where you pay for individual pieces of content. We're going to need to process payments. Now, that very, very often is not a synchronous operation. So let's say that the user wants to watch the latest and greatest piece of content, and they're paying for that on a transactional basis, and we need to take a payment of, say, $5 from that user. They make the request through API Gateway again. It comes into a different Lambda function, which is the function related to processing payment. But this time we put some information in Dynamo into the payments table to say we've started the payment, and then we start the step function, which will actually handle the process of going to the bank or the payment transaction processing service and interacting with that service in multiple steps, handling the state between those steps, retrying if it needs to retry, and finally receiving a response from the bank which says yes or no, payment accepted or declined. And so that's effectively triggered. The step function is triggered from that initial Lambda function, but the step function itself will invoke multiple Lambda functions along the way to achieve those individual steps.
Okay, I mean, that's really important. Something like payments needs to be idempotent. Lambda is actually a stateless service, so you need somewhere else to store state. So you can use step functions to take a stateless, asynchronous function and put it in to be idempotent for subscriptions, for payments, and for these other types of third-party APIs. So it's a good part of the architecture and something that is kind of an advanced use case for serverless. So one of the other things that we see in content creation and media really is DRM, so digital rights management. Studios are very worried about, who's viewing their content, how you're storing it, what locations. How are you achieving DRM with this setup?
Yeah, so rights management as a concept is incredibly important to the studios, and rightly so. They want to make sure that their content is protected. Now, there are a number of different vendors out there for DRM solutions. I'm not going to name them all here, but there are at least 3 common types that you might want to interact with. Now, for all of those types, the license issuing software and the encryption software does not run or is not capable currently of running inside of AWS Lambda. Okay. So what we need to do is when the user actually initiates the playback, they're going to route that request again through the common pathway that we've seen, and they're going to hit a Lambda function which is responsible for playback. And as part of that Lambda function, we're going to need to acquire a license for that piece of content and for that user's device, because it will supply a specific fingerprint. And we will supply a license back to that user that allows them to play the content under the terms of the rights that we have. So that DRM license that you receive might determine, can you play that asset offline? Can you play it more than once? Can you do things like play it after a certain date or before a certain date? Okay. So this Lambda function needs to acquire the license. And the way that we've represented that in this architecture is to run the licensing servers on a load-balanced and auto-scaled fleet of EC2 instances. Mm-hmm. So the playback request will be initiated, the Lambda function will call the licensing service. The key material that allows us to decrypt that asset, so the core key material, of which the license is effectively a subkey, might be stored in Cloud HSM, or it may just be stored within these licensing hosts, depending on the solution that you're using.
Yes, so some of our audience might not be familiar with HSM. Can you talk through what a HSM is, what kind of function it actually provides in this architecture?
Absolutely. So HSM is a hardware security module, and this is a tamper-proof hardware device that can securely store the key material within that device, and it's incredibly resistant to tampering, to software attacks, to even being pulled apart. If the case on that machine is opened, those keys will be wiped from the device and they're no longer available. And that can be built in a highly available shared key state architecture where you can share the keys between them. So you're not just reliant upon a single device. And we've turned that into a managed service. So the newer version of Cloud HSM allows you to do that very, very easy and simply. We've taken the headache out of managing those physical hardware devices and managing the key material within them.
Okay, and I guess this is very much the playback from the downstream provider side. So what kind of things we need to think about in the player and making the player smart? And how would we cover that?
So that is probably one of the hottest topics in recent times for this type of solution. As we've talked about already, that user experience is really, really critical. So from the time that the user hits play to the time that that first frame appears on their device and it starts playing the introduction, or the ident for that particular content provider, that time is really, really important, and we need to make it as low as possible. Now, the assets themselves, the video assets, are going to be stored in S3, or they may be stored in another origin service. They're going to usually have a CDN in front of them. Sometimes that will be multiple CDNs. So to make sure that you get the best experience for all of your users in all of the different geographies, you might employ a multi-CDN strategy. And this really leads back to the original question that you asked, which is what kind of smarts would you have in your player? Well, if you've got multiple CDNs and your user is out there in the sticks in the middle of nowhere, this business logic down here cannot really, make a good determination on what the best CDN for that user to choose might be. So this is where the player smarts become really important. It's critical that your player knows, which CDNs are configured for that particular geography or for that particular user even. It might take into account whether you have committed to have a specific amount of data to be transferred by each CDN. It might take that into the mix when it's choosing CDNs, but ultimately it's going to come down to performance. So the player up here might test, can I get the fastest possible response from CloudFront, the best possible bandwidth? Can I get that from another CDN? And it's going to use that sort of deterministic logic inside of the player to make that decision.
Okay. And I noticed you've got some Dynamo down here that isn't kind of plugged in. What was that part of your architecture?
Yeah, so this is to represent the fact that within Dynamo, we're not just going to store everything in one table. That would be crazy. We have multiple different data types here. So we have the user profile service that we talked about. But if we relate this to what we just talked about, the actual playback initiation, we might have a table that stores the location or the name of assets. So different devices need different asset types. They might need different packaging, they might need different resolutions. And we could store that in an asset table that says, for an iOS device, pick this particular packaging. For a tablet, pick a different resolution to what you might have on a connected TV. And so we're going to have multiple tables down here that store those multiple different data sets. Another example might be for the rights that we hold for a particular asset. And we'd store all of those separately.
Okay, so we've talked through the user journey. We have iOS, Android, and other devices that can access. We're using WAF for our security at the front. One thing around malicious actors might be something like rate limiting. Can you achieve that with the WAF, and is that something you've implemented in this architecture?
Yeah, so that's actually one of the native capabilities of API Gateway. And we would probably look to implement it here first. And at the point that that becomes ineffective or the request rate becomes overwhelming, what we might do then is use automated rules, either through a Lambda function or some other linking, to implement a WAF rule up here that blocks that IP address or that particular user set of credentials at the edge, rather than allowing them to come down to API Gateway.
One important part we haven't talked about here is authentication of users. I noticed that we don't actually have anything drawn on the board. Can you talk through how we're going to authenticate a user through this workflow?
Yeah, so there are obviously multiple choices out there, but the one that we would probably most likely use for this architecture is Cognito. Now, Cognito has native integrations with API Gateway, which would allow you to quite easily make use of something like Cognito user pools. Which can store obviously the username and password, but also other metadata about the user. So their profile data such as their address or their date of birth, things like that. It will also handle some of the really common tasks like password resets, for example, that you just don't want to spend time building business logic for. And that, as I said, has native integration with API Gateway, but you can also access it further down here inside of your business logic or using custom authorizers inside of API Gateway.
Okay, and it's also a very important part of collecting metrics on your users, such as playback, things like which bitrate the user is using, so that we can use that. And in a future episode, we're actually going to talk about how you put some smarts into those players to use those metrics. Thanks, Rob. That is episode 3 of Video on Demand Playback. Thank you for watching and stay tuned for episode 4. Hi, and welcome to episode 4 of Build Your Own Video on Demand. This episode is about search and recommendation. I am Sean from AWS, and with me...
Hi, I'm Steve Shirkey. I'm a machine learning specialist with AWS.
Okay. In episode 3, we talked about putting our user profile and our metadata into stores like DynamoDB. And today what we're going to discuss is search and recommendation. How do we get those recommendations and the search functionality up to the customer? Steve, we have our Dynamo here as our central piece as well as S3. Can you talk through how you would provide search to our users?
Great. So starting with that search component, we would obviously look at what existing metadata we have. It's all been provided to us. We have some manual information, perhaps some genre information that's been populated about those particular media files. We actually want to augment that information. We want to use some machine intelligence to do so. So first, because it is video, then obviously we're talking about the ability to use computer vision. So we actually have a service called Amazon Recognition that will allow us to extract metadata about the images as well as the video itself that's been stored in S3. So using perhaps image, if we have any kind of screen caps or anything that's coming out of the video, we're able to obtain object and scene detection. We're able to identify celebrities. We can identify very important people that basically match against a known set of users. We can identify all of these individuals and start to populate that with that augmented information. Second, we can use recognition video to scan those video files and do the same thing as before, but also we can identify motion context. So motion context would be things like the verbs. So the ability to see what is actually happening inside the scene.
Okay, have you got an example of like a verb detection that might be common?
Yeah, so you can imagine if you have typical image recognition, you'd identify a man laying on the ground and you'd identify him standing. You would be missing that component which happened between those frames. So the idea is that the person has fell, that would be identified as part of that motion context.
Okay, and so when you're talking about image as well, I guess this will allow us to do things like, actors who are not necessarily the title actors, who are put in the original metadata, some of the actual cast and crew where people will be able to search like down into these deeper layers.
Right, exactly. So then you catalog all that information, you append that additional metadata, and now you have that additional search functionality to be able to search on particular actors, other pieces of content about the objects, about the scenes that occurred within that video.
Okay, and the way that I guess recognition works and the image and the video detection, are users calling that to find this metadata, or do you see this as some kind of offline job that runs and populates?
So obviously it's all, it can be real time, it can be batch as well. So the option is that if you do have a live video stream, you can actually capture all that information directly. Most cases for this particular use case, you actually already have the pre-populated video in the S3 store, and you can trigger an action which essentially can be part of a batch process to capture all that data.
Okay. Another important part about video playback and video on demand is things like translation and things like closed caption and those types of what sort of services do you have in that realm?
So of course we often have audio along with the video. So the idea is that you can use something like Amazon Transcribe to be able to extract the audio and identify the particular text. So within that, the idea is it's multi-language capability. You'd be able to identify essentially what is happening inside the scene based on text. So it actually provides punctuation, provides a number of different languages as mentioned before, and you can essentially then take that text and gather even more meaning from that text. So a service like Amazon Comprehend allows you to mine inside that and identify key phrases, the entities that are described inside that text, as well as sentiment analysis, and identify the underlying language. Okay. It supports up to 100 different languages. Sure. So from there, if you want to do localization of that content, you're able to then do translate services, which supports up to 12 different language pairs, to be able to translate that to the particular user's native language.
Okay, and transcription, I guess, is kind of an art form in whether you're actually transcribing the text right. What happens if I do want to use kind of an automated pipeline here for things like closed captioning, but there are some things that are maybe specific words they use that they've invented in the movie that aren't really real words, these types of things. How is that going to work in this, and is there a way that we can short circuit that?
Yeah, so there's support for custom lexicon. So again, if there's industry jargon that's involved, or there's particular names that are trademarks or something that's not actually well known as a given text, it actually has support for those as well. So you can actually feed it a custom lexicon.
Yeah, and I guess on top of that, the other functionality that we provide with Transcribe is that it actually gives you a confidence score for each word. So for instance, you could go in and get someone manually to up the confidence of those particular words for the ones that you were missing, so that you wouldn't have to do the whole closed captioning.
That's a great point, Sean, because also most of the transcription services are manually performed, and things like identifying exactly when a word occurs is very difficult to do with those services. So you actually do receive not just a confidence score, but you actually receive the exact timestamp when that word was identified inside the audio.
Okay.
So you've created all this content, you've essentially augmented all the data about that content, and that obviously helps the users to be able to search and identify content that's relevant to them. But the next step, as you know, is going to be about recommendations. It's not enough just to simply have a database that's searchable. It's now you receive 10,000 responses to that search. The key is basically presenting to those users relevant results and identify content that they would be actually desiring to have an affinity with. So obviously we've performed that content. We have it stored in S3. Now the next question is where we go with that. We have the ability to mine that information about the users and about the content to identify similarities. So you can think about, when you think about user recommendations, we can identify similarities of the users, or we could identify based on similar products that they've purchased in the past or they've watched in the past and identified an affinity for that particular type of product, then you'd be able to recommend for them similar items.
Okay, and I see that there's a couple of workflows under here, under S3 and also up in the brain. Can you talk through, I guess, how that works in? You know, we've now got search, we've got 10,000 results. Mm-hmm. Like, I don't want 10,000 results. I'm a user. I want to see what I want to see. So
precisely. So obviously, we need to apply some machine learning to that. This isn't as simple as some of these API-driven machine learning services, the machine intelligence that we derive within these different services. Mm-hmm. We want to do something a bit more meaningful. So the idea is that the first step typically for recommendation engines is to identify clustering of users. Clustering of products as well, but it's not products looking for users. It's often users looking for products. Mm-hmm. So we need to think about how do we identify similarities between users. And certainly, if you think about a cold start scenario where the users just first come to the website, you may be obtaining information about demographics, you may have clickstream data, social networking information. We would use all of that, mine everything that we can about that individual to try to identify them and make a clustering to identify them as part of a general group. So something like SageMaker basically can do that process, but it's actually 3 different modules inside SageMaker.
Okay.
So we start with the idea that there's a notebook interface. So a lot of data scientists use notebooks in order to be able to interact with the data and do data exploration. So the idea is that they would pull the data from S3, which would be that user data that's perhaps started in DynamoDB, but essentially was explored and directly stored back to S3 for training. And once they've identified meaningful correlations and identified features that are meaningful to the experience of the user and recommendations, then they are able to process that for training. So for instance, for a typical clustering scenario, perhaps they're choosing k-means clustering within SageMaker, and they're able to perform that machine learning training based off of the data inside S3. So now they can run that, and they only pay for the amount of seconds of compute that's required for doing that training. Mm-hmm. And then as an output from that, it stores it back to S3, storing the model, which is actually then later used by SageMaker as a third part, which is the inference. So it provides you the ability to have a container that runs that model and provides then the interface from the user back to SageMaker to allow you to identify those individuals as being part of a particular cluster.
Okay, so one important point I guess you pointed out here is you actually train the model on the data beforehand, and then you're just providing inference. So you call up and say, hey, I'm a user, I want a recommendation. And so you've actually trained the model. It's not like you're churning all the CPU, the user is waiting. You know, we talked about in episode 3 about latency is the most important thing. And so what we're doing here is really training this offline. So all we're doing is getting an answer.
Absolutely. So as you said, Sean, you're often having to do that training over and over again as you discover more ground truth. The idea is that as we get more user information, the more that we understand those users as a whole. And so we identify that, we run those on batch processes, we basically do that training, and we continue to iterate and develop new models. So to your point, you often need to have actually several models. You'll have one that's the most recent, as well as one that's running in production, so you need a way of switching those models. So there's support for A/B testing within SageMaker endpoints, where you can now host both models and you can actually see the performance of the new model versus the old model and identify, is this a more successful model, and therefore switch that to the main production model.
That's an important point. I never really thought about running multiple models in production, and I guess as you iterate over time and you learn more about your cohort, you actually tune it so that you're actually running multiple different versions.
Absolutely.
I guess from now we've been talking really about the back-end data stores and how they interact. Can you talk through how the user kind of comes into this scenario?
Yeah, so users would often be accessing that through API Gateway. We had drawn earlier with API Gateway and the idea of CloudFront distribution. Those pieces are still there. We've just abstracted those for the purpose of discussing the machine intelligence portion. So the idea is that they would be accessing often an API Gateway. That would make sure that you're rate limiting, that you're supporting the security model, and assuring that users aren't having unfettered access to this endpoint, which is hosted by SageMaker. So you can build any business logic you wish. You could have Lambda functions happening here. You could have step functions, whatever orchestration required. But this is just one part of that overall story, right? Because when you think about recommendations, you have to present those on screen for the user. You have to identify in what context do you provide that. So it's still part of your overall web architecture.
Okay. So we've talked through the data stores and how they provide the data into the AI services so that we can train the models and do recommendations. How about the user journey in this workflow?
Yeah, so users will continue to access things like the DynamoDB store through Lambda architecture. They'll also be able to connect back to SageMaker, which essentially is connecting them back to the original SageMaker endpoints. So that flow of control and that amount of data bubbling up to the user will be through the same mechanisms as before, with the augmentation that we've now added SageMaker to that formula.
Okay, so here we're orchestrating with API Gateway, with step functions, with these types of things so that we can call out to recommendations. Okay. And then I guess one other thing, we talked before about k-means clustering, right? And that's one way to get a cohort and to understand, who to recommend to. But SageMaker provides a number of other algorithms. Do you think any would be, useful for search and recommendation?
Yeah, absolutely. So clustering is the most naive approach to obtaining some kind of result, and it's a great first step. But the reality is that there's many more sophisticated methods, and one of those particular that SageMaker offers is factorization machines. And from factorization machines, you're able to do matrix factorization. So put simply, it's the idea that once we identify affinity or similarity between these users, I want to understand why is it that you share this similar affinity as I do with a particular movie. The idea is to suss out what are the underlying factors. So those are called latent factors. And something like factorization machine allows you to identify what those factors are. And then from that, you can now calculate a wealth of other options in terms of producing recommendations to the user.
Okay, and how many in total, I guess, do we provide in SageMaker?
Yeah, so those two are k-means as well as factorization machines are part of SageMaker's built-in algorithms. We have 13 different algorithms covering a number of different use cases like linear regression, et cetera. But bear in mind that if customers come with TensorFlow or MXNet and they want to run on SageMaker, that's supported as a full API, and as well as they can run their own custom containers if they're running something like Scikit. Some other different approaches, if they want to run R, they can actually run it also inside this infrastructure for SageMaker.
Wow, so basically, even once we go through this kind of basic architecture of getting someone up and running, then they can also keep iterating, bring their own technology and make it much more advanced.
Yeah, that's exactly it. So the idea is that data scientists, whatever they may be doing today, developers, if they have no background in data science, they actually have a lot of different options within SageMaker to solve their business problems.
Thanks for coming in today, Steve. That was episode 4 of Build Your Own Video On Demand Architecture. In episode 5, we'll explore smart players.